The maximum node will always pick 0.15 if the first input is below this value. Now I want to increase the p-scale value only for a certain percentage. For that, let's create a ramp parameter. Choose a spline ramp. We also need the random node. Connect to it the PT num. The random values connect to the ramp. Now let's add these random values to the p-scale. As you noticed, nothing has changed because the default spline ramp is 0. Let's jump at the object level and set up a spline ramp. Choose a constant for interpolation type. Now we can control the percentage of random values that are not 0. That's it, so simple. Let's put a 0.95, which means we increase the p-scale only for 0.05% of tubes. Definitely, some tubes are very large. Let's do the final adjustment. We can fit the random values. Squeeze the new range from 1 to 0.5. Looks fine, we can move on. Now let's create a one more attribute VOP. This time we will set up the color. Dive in. I want to give a color based on the mask attribute. Let's bind the mask. Create a color ramp and plug the mask into it. The output of the color ramp connect to the CD port. Let's jump at the object level and set ramp colors. Looks cool. Now we can dive inside the attribute VOP and start to manipulate these colors. Create a hue shift node. This operator shifts the hue of the input color along the color wheel by the amount of the shift value multiplied by the amplitude. Plug to it the color. The output color connect to the CD port. Make a 1 the shift amplitude. Look, we can shift the hue of the input color. Okay, now I propose to drive this parameter by the time. First, let's create a sine node. Plug to it the time. Then we have to fit the sine output range. Look, the source range is -1 to 1, we shift it from 0 to 1. Now we will drive the hue shift with this modified time. Toggle real-time button, then play the animation. As you can see, the time cyclically shifts the hue input color. Okay, now let's delete these two nodes and try to drive the hue shift in a different way. This time let's use a relative bounding box information. Create a getVector component node, then extract a relative bounding box along X. Now let's shift the hue of the input color by the bounding box information along X. That's it, looks nice. We can also control the shift amplitude. Great, let's continue. Now I want to show you another cool node, which is an alternative to the hue shift node, and it is more advanced, with which you can manipulate the colors as you like. It is called color correction. This operator provides a means to change the hue, saturation, intensity, bias, gain and gamut of the input color. Plug to it the ramp color. The output color connect to the CD port. Look, now we can shift the hue. We also can control the saturation, as well as the color intensity and so on. Now let's randomize the hue shift for each point. This time, I will use a Gaussian random node just to generate positive and negative random numbers. Plug in the PT num. Decrease the sigma just to squeeze the range. Now let's drive the hue shift by these random numbers. That's it, as you can see we shift the hue randomly for each point. Let's tweak the sigma and see what it looks like. Looks cool, let's move on. Now I propose to animate these tubes. Let's jump at the object level and create one more attribute VOP. Call it animation setup and jump into it. To animate the tubes, we have to animate the normals because the tubes are directed along normals. To make sure, let's simply change the normal direction and see what happens. Create a constant node. Select a 3 floats vector. Set a direction along Y and plug to the N. N is a normal vector for each point. As you can see, now the tubes are directed along Y. Let's change the direction of the normal to make sure that tubes follow the normals. That's it, now let's try to manipulate the normals in a more interesting way. Create a cross product node. This operator computes the cross product between two vectors, defined as the vector perpendicular to both input vectors. In simple words, when we have two vectors, the dot product will make a vector that is perpendicular to both of them. Let's plug the normals as a first vector. For the second vector, let's create a constant directed in a positive y direction. Now the cross product node make a new vector that is perpendicular to the given vectors. Here we go, the tubes are flowing tangentially around the torus. To reverse the direction, let's change the order of input vectors. You can simply select the node and press Shift R. That's it, we reverse the direction. Now let's jump at the object level and see how the normals look. Let's display the scatter node and check the point normals. Normals also flow tangentially around the torus. Okay, let's move on. I want to adjust the tube properties a little. Let's put a 0.5 for the second radius. Then dive inside again. Now let's create one more cross product to get the double cross product between the normals and the result of the first cross product. Look, now the tubes flow tangentially from bottom to top. Let's press the Shift R to reverse the direction. The tubes flow tangentially from top to bottom. Okay, now let's delete these nodes and try to animate the normals. Let's create an anti-aliased noise. This noise can take on a 4D vector, which gives us an advantage for animating the fourth component. Let's choose a 4D input and 3D output from this menu. Take a look, these parameters became yellow because in the VOP context 4-dimensional vectors are specified yellow. Let's create a vector to vector 4. This operator converts a vector to a vector 4. Plug to it the normals. The 4D vector connect to the noise position. Add the noise to the normals. Connect sum to the N. Take a look, now we can animate the fourth component and make them move. Let's drive the fourth component with the time. That's it, they move when the animation is running. Let's tweak the noise amplitude and see what it looks like. We can tweak the frequency as well. Now I propose to add another vector with which we can imitate the directional wind. Let's direct it along X. Here we go, now they are curved along the X-axis, as if the wind is blowing. Of course we can control the wind influence by changing the X value. We even can animate the wind influence. For that, let's create a multiply node. As well as create a fit range node. Plug the frame to it. The frame is a current frame being processed. Look, since animation timeline starts at frame 1 and ends at frame 240, let's set the source min 1 and source max 240. We just fit this range from 0 to 1. Let's also create a spline ramp. Select the spline ramp. Wire to the ramp and multiply by this. OK, now let's set up the spline ramp. Something like this. Let's check what it looks like in action. Great, as you can see the influence of the wind changes. Let's dive in and increase the wind amplitude. That's it, the wind effect's much stronger. Let's put a -2 just to reverse wind direction. Okay. That's all for this lesson. In the next lesson we are going to discover a lot of new nodes and we will deal with orientation.